Hello boys and girls, this is Mr. Kizik, and this video here we're going to be looking at parallel lines that are cut by a transversal and what happens to them. So from that activity, what you should have seen was that corresponding angles, or let me just read the beginning. So if I have two parallel lines that are cut by a transversal, then the corresponding angles are congruent. The alternate interior angles are also congruent. The alternate exterior angles are also congruent. And then for the next two, the consecutive or same side interior angles and the consecutive same side exterior angles, they are both supplementary, or as we know, they add up to 180. So knowing this information here, along with what we talked about in the first chapter, knowing vertical angles are congruent and linear pairs are supplementary, we can figure out various angle measures. So let's start with the most simple, basic example here. For example, one's just asking you if they are congruent or supplementary based on type of angle. So we're actually going to look at example 2 here, just to see, a number specifically what happens. So it says angle 1 is 65 degrees. So then it says find the rest, and also it is very important to give your reasoning. Now, you don't necessarily need to, start at letter A here and go right away. You can start wherever. So for example, let's say I started with letter B, angle 3. I can say angle 3 is 65 degrees. And why is that? Because it's a vertical angle to angle 1. You can actually just make it vertical to angle 1. Okay. So angle 3 is 65. All right. Maybe you want to say now angle 2 is 115 degrees. Why? Because it's a linear pair to angle 1. Did I have to use angle 1? No, I could have said angle 3. I still would have gone 115. Which then means, okay, what's angle 4? Well, angle 4 is 115. Now, once you start getting more than one angle here, your reasonings can be different. So you might say, oh, it's a linear pair also to angle 1, which would be right. But I can also say it's a vertical angle to angle 2. Still the same reasoning. It's congruent to angle 2, so it's 115. All right, how about letter D, angle 5? Well, I could say angle 5 is 65 degrees. Why? Because it's alternate interior to angle 3. And angle 6, I can say, is 115. And again, I can have many reasonings. I can have it's an alternate interior to angle 4. I can talk about it's a same side interior to angle 3. I can also say it's corresponding to angle 2. All those reasonings are valid, and they all get you the same results. So I can say angle 7 is 65, because again, it's corresponding to angle 3. And I can say angle 8 is 115 degrees, because I could say, let's do a different reasoning here. We can say that it is consecutive exterior angle to 1. Okay. So again, these parts right here, the numbers, everyone should be getting those. Those don't change. It's this part right here that the reasons can vary based on, how you saw the picture yourself. So let's look at something that's a little more complicated, maybe example 4 here. So example 4 says angle 5 is 82. So I'm going to write that down, 82 right here, and define the rest. So what I usually like to do when we get to more complicated figures like this is I like to, if possible, find all the angles within that area, within that section. So in other words, I can find angle 8. Angle 8 and angle 5 are both 82 degrees because it's vertical. And then I can figure out what angles 2 and 11 are. So let me write that here. Angles 2 and 11 are both going to be 98 degrees because they are linear pairs to, so like angle 2 is a linear pair to angle 5. So they form a straight line. I do 180 minus 98, 180 minus 82. All right. So that takes care of the area I'm at there. Well, now how do I find the rest? This is where multiple things can come into play. I personally, and this is just me here, like to do next look at corresponding angles. So if I think about it, angle 2 is corresponding to what angles? Well, it's corresponding to angle 1 because let's just pretend this line wasn't here. So angle 2 would be corresponding to angle 1, so that means angle 1 is 98. However, let's just say this left side wasn't here. Well, angle 2 now is corresponding to angle 3, so that's also 98 degrees. All right. Well, how about the angle 8? Where does angle 8 correspond to? Angle 8 corresponds to angle 7. And angle 8 also corresponds to angle 9. They're both 82. And then I can do the same thing for the other side too. Angle 5 is corresponding to angle 4. Angle 5 is corresponding to angle 6. And then I can say angle 11 is corresponding to angle 10. And angle 11 is corresponding to angle 12. Could I have done it differently, but still get the same results? Of course. I could have said, oh, well, angle 5 and angle 10 are same side interior, so I do 180 minus 82. I still get the 98. All right, let's look at example 5. Example 5 says angle 12 is 121, angle 6 is 75, and to find the rest. So again, I like to look at these problems and say, okay, how can I get like the corner, the area that's in? So if I worked with, well, I'm circling in blue here, I worked with this area first. Well, angle 12 and angle 7 are vertical angles. So what do we know about vertical angles? They are congruent, so that's 121. And then we can figure out angles 11 and therefore angle 8 by knowing that 11 and 12 are linear pairs. So I do 180 minus the 121, and that gives me 59. So 59 degrees for angle 11, which is going to be the same thing for angle 8. Okay. So that helps me here. We can look at the other one with angle 6 here. Now, there's a lot of corners here per se, but let's just do what we know here. Can we do vertical angles? Yeah, angle 6 is vertical to which angle? Angle 1. So that's 75. Now, with this one here, there's nothing so far right now to help us define linear pairs or anything. So the next thing I want to look at is, do I have corresponding angles? And if I look at angle 6 here, yeah, angle 6 is corresponding to angle 14. So that's going to be also 75 degrees. All right, let's see any others here. Well, so now what I have here, I have another corner, another 4 angle area that I can figure out. So I know that angle 9 is 75 because it's vertical to angle 14. And then I can figure out what 10 and therefore 13 are because 10 and 14 are linear pairs. So 180 minus 75 would give me 105. So 105 degrees here, which means angle 13 is 105 degrees. Now, just to a side note here, because a lot of students are saying, well, isn't angles 11 and 13, aren't they corresponding? Because we learned in the first section that it's a transversal here, and it's being cut through with two lines. And you'd be correct. However, in terms of the number itself, there's no relationship between 11 and 13 in terms of the algebra of the number here. So let's see. Now we have 2, 3, 4, and 5 here. Well, again, you're treating these kind of like a puzzle. Well, I can figure out what angle 4 is first by looking. Well, angle 11 is 59. And it's corresponding to angle 4. So angle 4 must be 59 also. Again, I could have done a different approach and said, oh, well, 7 and 4 are same side interior angles, so they add up to 180. Ooh, which then tells me angle 3 is 59 degrees because it's vertical. Okay, good. So now I'm left with angles 2 and 5. Well, I can figure out what angle 2 is by realizing that I have a straight line here. We know it's a straight line. We know straight lines add up to 180, and there's 3 angles that make up that straight line. So I would have 180 minus the 75 and 59 added together. So in my calculator, I would do that. And I would get angle 2 is 46 degrees, which means angle 5 is vertical to it, so that's also 46 degrees. Once you start finding a couple of the angles, it does like a domino effect. You get the other angles too. All right, so there are other examples here for you to try out, but I just want to talk a little bit about the algebra here. Now, I might make another video with this, but just a little bit on the algebra. So the algebra, well, basically the bottom line is you want to identify, as it says here in the instructions, identify the type of angle, and by identifying it, that's going to help you determine how to set it up. So for number 1, what kind of angles are these? You would say they are corresponding angles. And the reason why they're corresponding angles is because one's outside my 2 parallel lines, one is inside my 2 parallel lines. It's in the same position here. What do we know about parallel lines or corresponding angles? They're congruent. So I set these two equal to each other. 58 equals 5x minus 2. And then I just go about solving for x, and I get x equals 12. Whereas, say I had something like number 4 here. What kind of angles are these? You would say that these angles are consecutive interior angles. The reason being is because they are on the same side of my transversal. Here's my transversal. And they're between my parallel lines. So, same side between my parallel lines. And what do we know about consecutive interior angles? They add up to 180. So, in this case here, I take 9x plus 2 plus 133, set it equal to 180, and then I just go about solving for x. So the hardest thing with these problems is just going to be actually this. What's the setup going to be? Once you find the setup, ladies and gentlemen, then the rest is just algebra, and you have the rest of the problem for you to solve here. Okay, so that, ladies and gentlemen, is parallel lines cut by transversal. Little examples of with just numbers and a little bit of algebra. So again, if you do have any questions or concerns, please feel free to reach out to me. This is Mr. Kizik signing off.